Hello, everyone. This is Professor Suneel Maheshwari. We will be going over class exercises in Chapter 13. In Chapter 12, you saw how you can use categorical variables as predictors variables in regression. So, for example, you can convert uh, we we converted categorical variable into dummy variable with value 1 or 0 to describe the two categories of the variable. For example, male and female. If it is male, then it is 1. If it is not male, it is 0, and so on. If it is free. Now, it is always common to refer to the category that assumes a value of 0 as the benchmark or the reference category. And then all comparisons are made in relation to the reference category. In Chapter 12, you use dummy variables to describe predictors with two categories. Now, it is also possible that you have got more than two categories of the variable. So, for example, if you are choosing about for the mode of transport to describe three categories, then it could be maybe public transportation, driving alone, and the carpooling. To define the three categories, we only need two dummy variables, D1 and D2. For example, D1 equals 1 for public transportation and 0 otherwise. D2 equals 1 for driving alone and 0 otherwise. For problem number 3. At this time, you should be able to see the connect part of the chapter on this. So in this case, a financial analyst would like to determine whether the return on a mutual fund varies depending on the quarter. So in an year, you've got 4 quarters. So you will need 3 dummy variables over here. And we collect the data for 10 years of quarterly return. And basically, you've got the data over here, which when you will run, will so in this case, return is given. For that particular quarter. So you've got quarter 1, quarter 2, quarter 3, quarter 4, and you've got the return that is given to you for those. So we need to estimate the y is equal to beta 0. B1 is the coefficient for dummy variable 1. B2 is the coefficient for dummy variable 2, and so on. Now, y is the mutual fund's quarterly return. D1 is the dummy variable that equals 1 if quarter 1 and otherwise 0, and so on. So when you estimate this data, this is what it is going to look like. The coefficients are given to you. So in this case, what does it tell you? The returns are predicted to be 3.64% lower in quarter 1 compared to quarter 4, because quarter 4 is the reference point. Similarly, return for quarter 2 are greater by 1.424 compared to quarter 4. Returns for quarter 3 are less by 4.45 compared to quarter 4. So how do you predict the mutual funds returns in quarter 2 and quarter 4? So if you look at quarter 2, you will set Q2 coefficient D2 at 1, rest D1 and D3 are 0, and so your D1 becomes 0, your D3 becomes 0. And when you compute it, I'll give you just those two numbers, the, the intercept term plus return for Q2 at 3.03. Similarly, you can compute for Q4 returns as well. Going to another example, which is number 4, you can, in a recent survey, ice cream truck driver in Cincinnati, Ohio, reported that they make about $280 in income on a typical summer day. So that's what they are making. The income was generally higher on days with longer work hours, particularly hot days and on holidays. The accounting data file includes 5 weeks of driver's daily income, number of hours on the road, whether it was particularly hot. So if it is hot, it is 1. If the high temperature was above 85, otherwise that was 0. So it is labeled as 1 category in the to explain that category of hot, and holiday also same way, it is 1, otherwise 0 if it is not a holiday. So if you click on this data, so you've got hot and holiday as your two variables, dummy variables. If it is 1, that is, it is hot on this particular date. And if it is 1 on a holiday, it is a holiday. Otherwise, it's not a holiday. So wherever it is 0, it is not a holiday. 1 is a holiday. And on these days, we are saying that income is related somehow, or can be explained, the variations in the income can somehow be explained by whether it is hot or holiday and the number of hours, obviously, that have been worked. So you can run a regression using the same technique that you have done earlier, which we have done a number of times. So your dependent variable is obviously the income, and your independent variable that you're trying to, which are predictors for your income, are these. So you get the intercept with 0.31 plus 31 for the hours, 92 for hot, holiday for 51. So 92 and 51. So that's the coefficient, and whether they're significant or not from the Excel that you ran just now. These are the coefficients. Now you should be very familiar with it. You can look at so this is not significant, and these 3 are significant in this case. Now predict the income of a driver using the following scenarios. If it's hours, 6 hours, it is hot and a holiday. So both are 1. So if you can look at it over here, both the hot and the holiday is 1, that will give you 333. If it is hot, but it is not a holiday, then this part is 0, and that will be about 282.69. So that is how hours 6, hot, non-holidays. Now, the next thing is extend the model to include an interaction between hot and holiday. Suppose it is both hot and it is also a holiday, then there might be an impact of or partial impact of one variable, predictor variable on the other. Now, how do you do it? You basically multiply the hot and holiday part variable together to get that coefficient. So at some places it will be so if you have to do it hot and holiday, so you've got hot times holiday. You've got a new variable there, hot and holiday, and obviously you can multiply the two. That creates your interacting variable, and you can copy it down over wherever it goes. So that's how you create the interactive variable for hot and holiday. Once you do that, your relevant regression when you run will be as follows. And then it goes to the same explanation as to how to use it for predicting income when it is hot and holiday, both hot and holiday, 1 and 1. And if it is hot but not holiday, then this becomes 0, because when you multiply any number by 0, it becomes 0. Thank you very much. Hopefully this would be helpful for you guys.